Hi, this is Mrs. Bustamante. This is going to be video number 2 in our descriptive statistics talk. And we left off saying that we were looking at our two data sets and that when we described them based on the center, they looked exactly the same. But we can tell that these data sets are not actually exactly the same. So I'm wondering, is there a way that we could look at this data in some different ways and see these differences or talk about these differences? And there is another way we can talk about this data, right? We can talk about this data in terms of the spread. And probably the way you're most common to talk about this or most familiar with is by talking about the range of this data. And the range of this data is just the highest value minus the lowest value. And what would that look like for our data given, right? Well, for set A, we would just do our highest, which would be 5 minus 1, which would give us a spread of 4. Our lowest value would be, for set B, would actually be 3 minus 3, which would give us 0, correct? So we could see these things really pretty easily. We said for set A, based on my data, it would be 5 minus 1, which is 4. And for set B, my range would be 3 minus 3, which is 0. So we, for the first time, see that we have some differences here, right? Range for set A is 4, and range for set B is 0. Already we can tell, okay, these data sets actually are different. So there's actually 3 ways for us to talk about the spread of our data, and in this video we're really going to focus on the second way. The first way is range. You're pretty familiar with it, right? The second way is something called standard deviation, and we're going to represent standard deviation as an S. And just like we saw mean written kind of interesting or average written kind of interesting, the formula for standard deviation is written a little bit interesting too. So the standard deviation is equal to the square root of, we say, the summation of x sub I minus x bar squared divided by n minus 1. So let's discuss what all these things mean. Well, x sub I minus x bar. Remember, x bar is our mean. So we're just solving the difference between every data point that we have and its mean. We're really going to square it here because we don't care if it is above the average value or below the average value. We always want this number to be positive. We have this summation because we're going to do the difference, or we're going to do this part of the equation for every data point that we have. N minus 1 is something called the degree of freedom. And it's going to come back later. But remember, n is just your number of data sets that you have, or data points, excuse me, that you have. So n minus 1 for ours would be 6 minus 1, so it will be 5 in a moment. And then the square root, why is the square root there? Well, the square root is really just there to get rid of this square value. So this is your standard deviation equation. You don't actually have to memorize this equation. You'll be given a formula sheet that has it on it, but I think it's good to understand it and understand the components of it. So let's go ahead and complete the standard deviation for the two data sets that we have. We have our data set A and data set B, correct? So let's look at standard deviation for set A. I wonder, can't really get them on the page very well, but we're still using our same set of data, so you can go back and reference it a little bit. So how would we do that? Well, we're gonna do our, I'm gonna do S sub A. So I know I'm doing the standard deviation of group A, so to speak, is going to be equal to, and I'm just going to go through my values. We said my mean or my average was 3 for set A. So it's going to be 1 minus 3 squared plus 2 minus 3 squared plus 3 minus 3 squared plus 3 minus 3 squared plus 4 minus 3 squared plus 5 minus 3 squared. Okay, so that's the sum of all my data values minus the mean. And then I'm going to divide it by n. N is how many data points I have. I have 6. So 6 minus 1. And I'm going to take the square root of this whole quantity. So I like to put this in parentheses again, just so I know it's that whole top number. This is where you might want to have your calculator to help you do some math, right? Okay, so the standard deviation of group A then is going to be, I'll put my parentheses in, and I'm going to simplify. -2 squared plus -1 squared plus 0 squared plus 0 squared plus +1 squared plus 2 squared. This is all going to be in parentheses. And I'm going to divide it by 6 minus 1, which is 5. And I'm going to take the square root of this whole number. So when I simplify this again, I get that the standard deviation of group A is going to be the 10 over 5, and then the square root of that, which means that it's 10 divided by 5 is 2. It's the square root of 2, which when I do on my calculator gives me that the standard deviation of group A is 1.414. I'm going to go ahead and fill that in on my table. 1.414, just so I can compare in a little bit. Now I'm going to do the same thing for set B of data. Remember, all the values in set B are 3, and the mean is also 3. So you're kind of going to like the math a little bit better here, I think. Because here we're going to do subset B. Standard deviation of B. Same equation, right? Except for this time, everything is going to be 3 minus 3 squared plus 3 minus 3 squared. Because my mean is 3 and all of my values are also 3. 3 minus 3 squared plus 3 minus 3 squared plus 3 minus 3 squared. 1, 2, 3, 4, 5, one more. Plus 3 minus 3 squared. That'll be in parentheses 2. My n value, I have 6 values, so it's going to be 6 minus 1. And remember, I'm going to take the square root of all of this. I'm going to do some simplification on my math here. I like to box my answers, and I forgot to do that a second ago. And I'm going to tell you that 3 minus 3 is always 0. So it's going to be 0 plus 0 plus 0 plus 0 plus 0. And 6 minus 1 is going to be 5. So I'm going to simplify. I'm going to say my standard deviation of B then is the square root of 0 over 5. Anything with 0, and the 0 is in the numerator, so it's okay. That means the standard deviation of group B is 0. That's my answer. And I'm going to go ahead and record that on my table as well. 0 as my standard deviation. Again, we have a difference when we look at the data. So what does the standard deviation tell us? Because right now these are just numbers to me. They don't really have a big meaning. Standard deviation is going to tell us how spread out my data is. So standard deviation is going to tell me how spread out my data is. So you'll notice in group A, right, in set A of our data, we had a wider variety of numbers, everything from 1 to 5. And my standard deviation was 1.414. In group B, I had the same number over and over and over again. I didn't have a lot of variety, if you will. That means my standard deviation is 0. So the bigger the number in your standard deviation, that means the more spread out or the bigger the difference between your data points. The smaller the number means that your data is more consistent. Maybe you got the same number or close to the same number over and